55 seconds, the first Delta cryogenic second stage, or DCSS main engine burn begins. During ascent, NROL-71 is protected inside a 5-meter diameter payload fairing. At approximately 6 minutes 6 seconds, the payload fairing is jettisoned.
ULA is using a Delta IV Heavy rocket to launch the NROL-71 mission. This is the 38th Delta IV launch since the inaugural flight in 2002 and the 11th flight of the Heavy configuration. Produced in Decatur, Alabama, the Delta IV Heavy, the nation's proven heavy lift launcher, is comprised of 3 common booster cores, each powered by Aerojet Rocketdyne RS-68A engines, and a Delta cryogenic second stage powered by an Aerojet Rocketdyne RL-10B2 engine. The NROL-71 payload is protected during ascent by a 5-meter diameter payload fairing. Let's have a look at a few of the events that took place in preparation for launch. On October 26th, the spacecraft, encapsulated inside the payload fairing, was transported to the Mobile Service Tower, or MST, at Space Launch Complex 6 and mated to the Delta IV Heavy rocket. The Mobile Assembly Shelter, or MAS, was moved to its launch position. The MAS protects the Delta IV rocket from the wind and fog so common to its location here on California's Pacific coast. Final launch preparations at Space Launch Complex 6 begin with rollback of the Mobile Service Tower, or MST. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the MST was raised 8 inches and rolled back, revealing the Delta IV Heavy. At 100 feet by 100 feet by 300 feet, the MST is as tall as a football field is long, as wide as the length of a basketball court, and weighs in at about 10 million pounds. Using a carriage transporter system traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its launch position 300 feet east of the rocket. The Delta IV Heavy stands 232 feet tall, or about 23 stories, and weighs about 1.6 million pounds fully fueled. The 3 Delta IV RS-68A main engines produce more than 2 million pounds of thrust. Approximately 6 minutes later, at stage separation, it weighs just 7% of what it did at liftoff. The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its innovative intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. The art for today's mission depicts an eagle as the symbol of both freedom and the nation, providing a fitting mascot to represent NRO's support to our nation's warfighter. The initials JLC on the foreground dog tag are in honor of Colonel Joshua L. Chamberlain, a Union commander who was awarded the Medal of Honor for his heroism at the Battle of Gettysburg on July 2, 1863, when he held the Union Army's southern flank at Little Round Top against a repeated assault from Confederate forces. Colonel Chamberlain's heroism, leadership, and commitment to service before self exemplifies the ethos of the American warfighter who the NRO is committed to serving each and every day. The art also includes the NRO mission number NROL-71, along with the Delta IV Heavy in Vandenberg Air Force Base to indicate both the launch vehicle and location. The motto, "Serving Those Who Serve," rounds out the logo and represents the NRO's commitment to delivering the mission on time to the warfighter and intelligence community. We remain in the 15-minute hold. Again, this is a planned hold to give the launch team time to resolve any final outstanding issues. If you're a regular viewer of ULA's webcasts, which we hope you are, or if you've been following the mission, you know we've had some technical issues. Last week, I had the opportunity to discuss those with Jim Zimmerly, ULA's chief engineer. So thanks, Jim, for taking some time out of your really busy schedule to talk with me today. I just wanted you to maybe talk to us a little bit about the scrub in December that was due to a hydrogen leak. How did we actually identify where that leak was? Like, what tests did we do to find that out?
Yeah, so as part of our standard process, anytime we launch the vehicle, we have a HAZ gas system that monitors all the conditions in the vehicle to monitor for any excess hydrogen, any excess oxygen, or any other propellants. During our launch attempt, we saw elevated readings. We did some troubleshooting on the day of launch and could not identify where the hydrogen leak was coming from. So we had to scrub that day and go initiate an investigation to figure out where the hydrogen leak was coming from.
What kind of steps have we taken to identify where that is and remedy the problem?
Yeah, unfortunately, when you work with hydrogen, the leak only showed up when we're at liquid hydrogen temperatures, only at -423. And there's no evidence once you're done, once you've detanked and got back into the vehicle, to tell you where the leak comes from. So what we had to do is initiate a tanking test. We create a special configuration with the engine section to have HAZ gas monitors at all the locations that were suspect for the leak, repeated the hydrogen tanking test, and then identified the source of the leak. We identified a valve on the engine that was leaking, so we went in and removed and replaced that valve. And then we repeated the tanking test just to make sure we had found the location of the leak and put ourselves back into a configuration that was acceptable for launch. We successfully completed that test, and now we are ready to get back into launch.
On an earlier attempt, we actually had a pretty visual scrub where we had a launch abort during the T-minus 10 seconds and counting. Could you kind of explain to me and the viewers what happened there?
For the last 10 seconds of our launch attempts, what we have, the terminal count sequencer rack takes control of the vehicle, makes sure everything is ready to launch, starts the engines, and allows the vehicle to take off. The data that we saw, that we can see, shows that the valves did properly switch from the ground to the flight configuration. Unfortunately, the electrical signal back from the vehicle that confirms that that position switch occurred properly, we didn't get that feedback from the vehicle that it switched properly. So the system automatically aborted before we started the engines because we hadn't got verification that we had the proper configuration of the vehicle.
Right, so essentially, you know, everything did work as intended, even though there was some smoke and flame.
Yeah, the system is definitely watching to make sure we're in the right configuration. It monitors it and will shut the vehicle down to make sure we don't launch in an improper configuration, and that's exactly what it did.
So obviously a lot of time and effort and energy has gone into fixing this, so really looking forward to launch, and thank you again for taking some time to talk with me today.
Right, thanks.
Brief of the three issues that have been discussed and outbriefed on Net 6.
Today's mission is ULA's first in the new year. 2018 also began with a mission for the NRO and included the first Mars mission from the West Coast and the bittersweet last flight of the venerable Delta II. Let's take a look back.
Liftoff of the United Launch Alliance Delta IV rocket, preparing the NROL-71 mission.
Liftoff of the Atlas V rocket.
Liftoff of the Atlas V, goes S.
Liftoff of the United Launch Alliance Atlas V rocket with Space 11.
Liftoff of the Atlas V and NASA's InSight.
Indication spacecraft set.
Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Liftoff of the final Delta II.
And liftoff of the AEHF-4 mission carried by United Launch Alliance Atlas V rocket.
The team is fully prepared to monitor those conditions. So that concludes my outbrief on that one, LC.
LC concurs. LD?
LD concurs, and we'll take the short version on next two, please.
Roger.
MD?
MD concurs.
All right. Second item was the swing arm ready indication on the PLC, and CGLS team went back and determined that they had a command timing issue with the PLC.
We remain in the planned 15-minute built-in hold. In a few moments, launch conductor Dylan Rice will poll the team for the final go to pick up the countdown. 31 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Western Range.
The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants.
We were seeing approximately 22%. That is the op limit for that item. We also have a red line limit at 23%. So oftentimes when we have wind indications, high winds, we see high indications on these alarm parameters. We continue to monitor in the starboard location via the RLM, but recommendation is to disable 6 line items associated with the port and core location. And I can provide those to LC after we get concurrence here. But team concurred or recommended to proceed into launch with those 6 alarms disabled and just monitor on the starboard location. That concludes that out brief as well, LC.
LC concurs. LD?
Concurs.
MD?
MD concurs.
And LC line items are 0988, 0989, 0990, 1000, 1001, and 1002. Those are the 6 line items to disable an RLM.
Roger. And RLM LC?
Go ahead.
You're prepared to implement the anomaly team's recommendation at this time?
Affirmative.
Proceed.
And LC, we also want to make sure we disable line item 587 for the PDOT measurement as we're manually monitoring that.
Roger.
Toll minus 5 minutes.
LC, this is RLM.
Go RLM.
All the limits discussed in the anomaly discussion have been disabled.
Roger. LD, LC net 1.
LD on 1.
Yes, sir. Given the late breaking anomaly discussions, I need additional time to complete the final steps of the countdown procedure before we're ready to proceed into terminal count. Recommend we extend the built-in hold.
Concur.
And so for the team on net 1, we will not be proceeding with a window open launch event. OSM, LC net 1.
Go LC.
Verify the hold fire switch is in the proceed position.
Ready to proceed.
Red line monitor, LC.
Go ahead.
Verify red line monitor and event table are in the correct configuration for terminal count.
We're active to give me 1 minute.
Roger. RC, LC 1.
RCN1.
Verify solar radiation limits acceptable for launch.
That's verified.
Flight control, LC.
Flight control.
Perform launch on time verification.
Roger.
LC, this is RLM.
Go.
Red line monitor and the event table are in the correct configuration for terminal count.
Roger.
And LC flight control, launch on time is verified.
Roger.
LC, LD on 1.
Go LD.
Please coordinate a new T0 of 19:10 Zulu.
Roger. 1910 Zulu. RC LC 1.
This is the RCN1.
Please coordinate a new T0 of 1910 Zulu with a range.
Roger, new T0 19:10:00.
ALC. Please set the countdown clock for a new T0 of 1910 Zulu.
Roger.
LC, ALC.
Go.
Countdown has been set for a new T0 of 1910 Zulu.
Roger.
The team is now working to an 11:10 a.m. Pacific launch time after resolving some issues and extending the hold.
Terminal count. First stage systems. Propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems. Locks.
Go.
LH2.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
TC cubed.
Go.
Operation support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HASGAS.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicles ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 set for 1910 Zulu.
Verified.
MEQ, establish swing arm lock pins, pull.
Active.
Polling is complete and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, we will enter the terminal count and begin securing the second stage liquid oxygen tank. At T-minus 3 minutes and 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, including closing the propellant fill and drain valves. Also at T-minus 3 minutes and 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized and confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute and 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, Western range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. At T-minus 15 seconds, the ROFIs are ignited at the base of the vehicle to burn off excess hydrogen. At T-minus...
And counting. 3 minutes, 55 seconds.
Ground pyros enabled.
Second stage lock secure at flight level.
The countdown clock has resumed and we are go for launch at 11:10 a.m. Pacific.
Three minutes, 25 seconds. Three minutes, 7 seconds. Two minutes, 49 seconds.
FTS internal. CPC locks at flight pressure and flight level.
T-minus 2 minutes.
Vehicle internal.
Hydraulic pressure 4,000.
1 minute, 55 seconds.
Launch sequencer start.
CBC LH2 at flight pressure and flight level.
One minute, 40 seconds.
FCS launch enabled.
1 minute, 37.
T-minus 90 seconds. The launch vehicle, payload, ground systems in Western Range are go for launch.
1 minute 20.
Both fuse armed.
FCS count started.
T-minus 1 minute.
T-minus 1 minute.
Engine start box go.
Rock, report range status.
Rock, range is green.
50 seconds.
Second stage, LH2 secure at flight level.
Seconds.
Status check.
Go Delta.
Go NROL-71.
Brophy ignition.
T-minus 10, 9, 8. We should have ignition. 6, 5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Delta IV Heavy rocket with NROL-71 for the National Reconnaissance Office.
Flight vehicles beginning the pitch over maneuver.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Now 20 seconds into flight, seeing good chamber pressure across all three R68A engines. Now 30 seconds into flight. And core boosters beginning to throttle down to the partial thrust mode as expected. Core boosters reach partial thrust. Now 46 seconds into flight. Chamber pressures continue to look good across all three R68 engines. Core booster in partial thrust mode, port and starboard boosters in the full thrust mode. Now coming up on 1 minute into flight. Now passing 1 minute, 10 seconds. All three RS-68A engines continue to look good. Vehicle is now passing max Q, maximum dynamic pressure. And vehicle is now past Mach 1. Delta IV is now supersonic. Now 1 minute, 30 seconds into flight. Chamber pressures on all three RS-68A engines continue to look good. Core booster in the partial thrust mode, port and starboard boosters in the full thrust mode. 1 minute, 40 seconds in. Launch vehicle is now 12 miles in altitude, traveling at almost 1,600 miles per hour. Chamber pressures on all three engines continue to look good, coming up on 2 minutes into flight. Second stage attitude control system press valve has been opened. System now pressurizing to flight levels. Response looks good. Now 2 minutes, 10 seconds in. Chamber pressures on all three engines continue to look good. Vehicle's now gone to closed loop guidance. Vehicle body rates look good. Now 2 minutes, 30 seconds in. Just over 3 minutes now remaining in the boost phase of flight. Engine operating parameters continue to look good. Now passing 2 minutes, 42 seconds in. The Delta IV rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 5,000 pounds per second. 2 minutes, 55 seconds in. Vehicle body rates continue to look good. Now at 3 minutes, vehicle is now passing Mach 5. About 20 seconds remaining, and I'm sorry, 30, correction. Vehicle body rates continue to look good. Chamber pressures on the RS-68A engines continue to look good. Now coming up on 3 minutes, 20 seconds into flight. Just over 30 seconds now remaining until strap-on booster engine cutoff. 3 minutes, 30 seconds in, just over 2 minutes remaining in the boost phase of flight. Vehicle is now passing Mach 10. Chamber pressures on the R68 engines continue to look good. And port and starboard booster engines now throttling down to partial thrust in preparation for cutoff as expected. And we have cutoff of the strap-on engines, standing by for separation. And we have good indication of separation of the port and starboard strap-on booster. Core booster is now throttled back up to the full thrust mode. Engine response looks good. 4 minutes, 10 seconds into flight. Chamber pressure on the core booster in the full thrust mode looks good. Upper stage lock system has begun boost phase chill down sequence to begin thermal conditioning of the upper stage engine. Now 1 minute remaining in the boost phase of flight. And upper stage fuel system has begun boost phase chill down. Core booster continues to look good in the full thrust mode. Coming up on 5 minutes into flight, a little over 30 seconds now remaining until BECO. Vehicle body rates continue to look good. Chamber pressure continue to look good on the core booster. Now 5 minutes, 20 seconds, standing by for core booster throttle down shortly. Core booster is now throttling down as expected, standing by for BECO. And we have BECO booster engine cutoff, standing by for stage separation. And we have good indication of stage separation. Nozzle extension is now deploying. We have pre-start on the RL-10, standing by for ignition on the RL-10. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. Standing by for payload fairing jettison. And we have good indication of payload fairing jettison. Chamber pressure continue to look good on the RL-10 engine. This first burn of today's mission will last approximately 12 minutes, 6 seconds.
This is Delta Mission Control at T plus 6 minutes and 30 seconds and counting. Patrick Moore has just confirmed the successful completion of the early phase of today's flight. All systems continue to operate nominally, and I would also like to thank Patrick Moore for his support of today's show. If you'd like to know more about ULA or the Delta IV Heavy rocket, visit ulalaunch.com or join the conversation on Facebook and Twitter. If you'd like to know more about the NRO, visit www.nro.gov or follow them on Facebook and Twitter. To finish the show, let's take another look at today's liftoff, which occurred at 11:10 a.m. Pacific. I'm Tyler Strickland, and on behalf of the entire launch team, thank you for joining us and have a great day. 1 and liftoff of the United Launch Alliance Delta IV Heavy rocket with NROL-71 for the National Reconnaissance Office.
Vehicles beginning the pitch over maneuver.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Now 20 seconds into flight, seeing good chamber pressure across all three R68A engines. Now 30 seconds into flight.